Well, welcome back. Glad you're here for a bit more. And so for the rest of you, I'm assuming there's some level of knowledge about Cosmos DB, and you're not here to necessarily dig into other aspects outside of security, because this session is focused on security, securing Cosmos DB. And as some of the folks here know, from Tuesday, we spent a lot of time the entire day digging into many, many aspects of Cosmos DB, but we avoided security because that's what I'm talking about today, this morning. So good morning. For how many of you is this your first SQL bits? Okay, okay. Most of you have been long-timers, I expect. Yeah, SQL bits been around for a while. Last time I spoke was 10 years ago. But it's good to be back, and with 1 minute till we officially start, I can just tell you a little bit more about myself. My name is Leonard Lobel. I run my own company back in New York City called Sleek Technologies. I'm a Microsoft consultant with Ernst & Young and a data platform MVP for the past 11 years or so. Do lots of training, speaking, writing, Pluralsight courses, so very much a lot of the content that I cover in these presentations can be, you can dig deeper into it on my Pluralsight courses, which can run 6-7 hours in total. With that, it's exactly 10:10, and I'm going to jump right in. It's a tight session. This is usually a 75-minute session. I can get it down to 60. Getting it down to 50 is a bit of a more challenge. So for demos, I've created some visual demos to speed the process along, but still give you the sense of a live demo, and of course some cool live demos as well. This link doesn't work yet, but it will if you want to snap a shot of it. I mean, it's going to include. It's going to take you to my OneDrive where you can download this deck, as well as my entire suite of code. I have a whole solution here, as you can see in Visual Studio. I have it drilled into security, because that's what we're covering now, but you'll have access to all the code, the entire solution, the full workshop from this link. All right? All right, let's dive right in. Oh, yeah, sure. No, there's always one. That's good. All right, excellent. So let's dive right in. There are 3 parts here that we'll talk about. We're going to talk about network level security using the IP firewall or VNets, and with the VNets you can use service endpoints, which are public, or private endpoints to really get Cosmos to be locked down. We will talk about authentication options, so if you have even the slightest familiarity with Cosmos DB, you know that the most common way to connect is you supply an endpoint and a master key. But there are limitations with that, or at least there are considerations with that, which might make you want to choose as an alternative authenticating with either resource tokens or the latest and greatest Azure AD role-based access control through Active Directory against your Cosmos DB account. And encryption, right? So our 3 pillars of security that we'll cover as quickly as we can in this time that we have for the session will be encryption, where we'll talk about server-side encryption, where there's not much to talk about because it's just kind of built-in, transparent. You can't turn it off. It's always there. But then, of course, the much more interesting and compelling client-side encryption, also known as Always Encrypted. Yes, if you're familiar with Always Encrypted in SQL Server, which was introduced back in SQL Server 2016, actually, this is building on, this is the same concept. And we're going to see those demos as well. All right, let's jump in with the network level security. So Cosmos DB is a public service, and it runs on the public internet, and therefore it exposes a public endpoint. And that makes it extremely convenient to get started, right? You can connect from anywhere, but for production environments, it's clearly way too much exposure, way much more exposure than you would ever want to allow for a production environment. You would want to lock things down. And so instead of allowing the entire public internet access, you will want to implement the firewall. And this is really a very simple but effective and powerful mechanism. I mean, it works like It works like any firewall does, right? You approve a set of IP addresses or a range of IP addresses, and only those IP addresses are allowed to flow through the firewall and hit Cosmos DB, which is still being exposed via its public endpoint at this stage. So Cosmos DB exposes a public endpoint, and you have two clients with public IP addresses, but you have set up the firewall, and you've only approved the IP address of the first client, so that traffic is allowed to flow through the firewall, but you have not approved the IP address of other clients, and so they are blocked by the firewall. Yeah, not much to talk about there. I mean, this is just right there in the networking tab there on the left. When you are in when you're in the Azure portal, and you are navigating your account, you can click on networking, and you will see the options up there for public access and private access. And by default, all networks will be selected, right? That's the fully exposed, completely open network. Now, so this is network level security. So this is your outermost tier, your outermost layer of security. So you basically, if you can't even get network packets to flow back and forth, it doesn't matter what credentials a hacker may have obtained, right? So this is your first. These are not mutually exclusive. Ideally you layer these security measures on top of one another, and instead of choosing all networks, you would choose selected networks, and there you just go ahead and fill in. There's actually two halves to this screen, right? The top half are virtual networks, which we'll look at in a moment, and the bottom half where it says firewall, that's where you just plug in those IP addresses or IP address ranges, including the auto discovery of the IP address of the machine that you're on for convenience, and then do take note of these checkboxes here at the bottom where you would almost never want to check that first checkbox. That basically bypasses the firewall for all public Azure services, including those belonging to other customers. And there would only be very specialized reason why you might need to do that if for whatever reason some service needs to access your Cosmos DB account and you can't get it as public endpoint, it doesn't expose a public endpoint or whatever it is, or IP address, and you just can't add it to the firewall, so you check that first checkbox. But normally you would never want to check that first checkbox. You would want to check the second one, which opens the firewall for a subset of the so-called middleware IP addresses that, let's say, the Azure Data Explorer uses in the Azure, the Data Explorer in the Azure portal uses, right? If you want to still be able to have Data Explorer access to your account via the Azure portal, you just check that checkbox. Go ahead and click Save, and it happens much quicker with these prepared slides, but in fact, you can wait 5, 6, 8 minutes. Because of the distributed nature of Cosmos DB, you have to wait that length of time for it to propagate, not like Azure SQL database, you pop in the, boom, in 3 seconds, you can get in. So any changes, you can expect to wait a little bit of time, but at that point, the firewall will be updated, and you will have effectively approved only specific clients by IP address, which can be tedious. And from a management perspective, you can achieve the same level of network security using VNets, where you don't have to manage individual IP addresses. You have virtual networks, and only the resources inside approved virtual networks, whatever their IP addresses may be, is able to flow through the firewall. And still in this scenario, Cosmos DB has a public endpoint that it exposes, but now I've got a set of clients all living inside of a VNet, and only that VNet is approved via a so-called service endpoint, which talks right to the public endpoint exposed by Cosmos DB, but other clients outside that VNet cannot, or outside any other VNets that you might approve. Now, if you go inside, this is a little small. Let me try to make that a little bit bigger. If you go inside, let's say the VM, a VM inside that VNet, and you do an NS lookup on your Cosmos DB account, you will see a public IP address. There's the 40.78, right? So it's still being exposed by a public endpoint, and therefore there is still a concern here. Yes, it's true that only clients inside the VNet can access your Cosmos DB account, but then those clients can exfiltrate, as the word is used, export, if you will, the data outside the public internet, right? Because the VNet resources themselves are exposed to the public internet, accessing Cosmos DB via its public IP address, and so therefore, if that's a concern, and it's not always is, but it could be if you want to really lock things down, you can go with, well, this is just screenshots showing how you can just add ordinary VNets, but in terms of exfiltration, here I just added a VNet. Like all the resources in that VNet can access Cosmos DB, but the VNet itself has exposure to the public internet, and therefore we want to go with, right, so that's the problem we want to avoid. Yes, only those approved resources can access Cosmos DB, but they themselves can export that out to the public internet. And if you have a rogue authorized user that has gone rogue and decides to access that data and pull it out, and you want to protect against that, you go with the third option. And this is a VNet through a private endpoint. Now, private endpoints, as I'm sure many of you may know, are not unique to Cosmos DB. It's also, the marketing term is private link. And it's the same concept for a number of Azure services where, again, you only can connect from approved VNets, but at that point, Cosmos DB no longer exposes a public IP address, only a private IP address. And that private IP address is accessible only from the approved network, which itself has no public IP addresses. So, I mean, technically, there is still a public IP address for Cosmos DB, but it is practically disabled, effectively disabled, and now there's only a private IP address on Cosmos DB. And so inside of that VNet, where you have a number of resources or services, what have you, that are approved to connect to Cosmos DB, you also create a private endpoint. That is a resource that you create, standalone resource you create on its own inside that VNet that can talk to Cosmos DB on its private IP address. And if inside of this VNet you do if inside a resource of this VNet you do an NS lookup, you'll see a private IP address being resolved by the DNS, right? For your Cosmos DB account. It's a 10.0 address right there. Okay? So there's no way now that an application that can connect via this private IP address can in any way exfiltrate the data out. And we're just getting less and less trust, right? We're trying to get zero trust here, right? So that's network level security. This is a bit of a demo walkthrough of how you set up the private link. You go to private access, and you click new private endpoint, and this takes you to a separate area. You're creating, again, a private endpoint which can be created against a number of different Azure services, not just Cosmos DB. You give it a name, like my private endpoint, and you choose the resource type, which in this case is a database account, Azure Cosmos DB database account, and the resource is the name of the account, and the sub-resource is not really important. It's the, what do you call it? It's the selected API for the account, and normally there's only one, so it's silly there's a drop-down, but there are cases where there could be two, but it's not really important. The point is that you're creating an endpoint specifically to the SQL API of that particular Cosmos DB account. And there's the virtual network setting. There's that DNS magic that happens automatically, like where I showed you how you get it resolved to a private IP address versus a public IP address, is achieved by the private DNS zone that you get automatically if you create yes. But if you want to manage your own DNS, no problem, just check no, and then you'll have to manage that resolution yourself. You go through the create process, and at that point you can go to the resource. There it is, my private endpoint is approved. If you go back to public access, you'll notice now that all networks on the left there is actually grayed out. It's disabled. It cannot be chosen. Once you have one or more private links, you can never choose all networks, right? Because it's not all networks. It's limited only to to private IP addresses on those private links that you've configured. In combination with these firewall settings, you can supplement the two. You can have your private links and you can have some firewall exceptions here, but you can never choose all public networks. All networks cannot be selected due to this account having approved private endpoints is the tooltip that explains why you can't choose all networks anymore. Yeah, so I'll pause to see if there are questions around the network level security that we just covered. I'm just going to do a quick time check to make sure that we're on sched. As we switch now to talk about resource tokens. Are we good? Yes, sir.
What's the cost implication?
Cost implication?
Is it expensive?
Yes, I don't think are any charges applied for you to configure the I mean private link? Oh, private link. I mean the firewall, so I think just plugging in IP addresses, no cost there. A private link, yeah, there could be costs. But if you remember from the other day, you know better than to ask me about cost. No. Yeah, there could be some costs involved in configuring and managing that resource. I think it's fairly nominal. So, what private link costs, couldn't say offhand, or if it does. Yeah, so that's kind of part one, right? We want to not even let you in the fence, the outer gate. So even if you have the keys to the front door, you can't get to the front door if you have network level security in place. Once you've gotten past network level security, now it's time to authenticate and authorize. And like I said, for the longest time, this has always been based on a combination of the endpoint, which is the name of your account, essentially, and the master key, which is your master password, essentially. Your master all-in-one password that if you have it, you can do anything and everything. And if you don't have it, you can do nothing. And there's no granularity between those two things. So any kind of user authorization or permission-based configuration that you need to implement, you need to do it yourself at the application layer because it's not supported with a master key. There are two alternatives, however, to using the master key that do give you this granularity. One of them is as old as master keys, and that's the first one that we'll talk about, resource tokens. They're interesting, and we'll cover them because they're part of the essential understanding of the your overall options for authentication. The first one being master keys, all or nothing. The second one being resource tokens, which we're covering now, and the third one being much more compelling, which is Azure Active Directory. So let's go in order here. What are the concerns with the master key? I kind of just enumerated them. Full access. You can also have a master key that gives you full read access, but beyond that, no granular control, right? And in all the demos, you'll always see it in clear text, right? But it can be secured in Azure Key Vault as well, so that it's not exposed as a secret in your app settings. But you can also use resource tokens as an alternative and gain this granularity because you can then say that you can distinguish between full or read-only access at the container level, the partition level, the document level. All right, so if you imagine a multi-tenant scenario where you've got the tenant ID is your partition key. Every tenant has their documents in their own partition. They can have up to 20 gigabytes of data inside their partition, as you know, right? Maximum logical partition size. So you are partitioned on partition key. With resource tokens, you can ensure that each tenant has only access to their data by securing a resource token at the partition level. Or it could be at the overall container level, it could be at individual document levels, as well as store procedures, triggers, and UDFs. And it's a fairly simple process. I'm not going to run through the demo because I think the Azure AD is much more pertinent and relevant today. But the process is that you basically define users and permissions. And you create those users at the database level, and then you create the permissions at the user level. So you define users, Tim, Mary, John, and so on. And then for each one, you define permissions. And then from each user's permissions, a resource token can be generated. And if you then connect using that resource token instead of the master key, you will have restricted access based on the permission or permissions. If you have multiple resource tokens based on multiple permissions, you can connect with that set of resource tokens. And you will have that restricted access. So really the downside here, and maybe I'm jumping the gun a little bit, is that most of us already have defined our users, and this is now an additional burden to define them again in the database. Most of us have our users in the form of some Azure Active Directory somewhere. And it's much more convenient to authenticate our applications using identities that are managed there than doing it this way, but this way works too. And this approach with resource tokens also has a unique aspect to it that's different than the other authentication methods, as I'll show you in a moment. So let's say you have a client app. You would have a middle tier, and you would authenticate it, but against the client, right? You would authenticate the client against whatever works for you. It could be Azure AD even, but it could be Okta, it could be any form of authentication. Somehow you authenticate the user. And based on your knowledge of who that user is, you get the permissions defined for that user. And you do that by connecting to Cosmos DB using the master key, right? So this is kind of like a authentication flow. And when you get the master key, when you get the permission or permissions, you get back one or more resource tokens, and you pass those resource tokens back to the client app. And after that flow completes during the one-time sign-on process, you use only the resource tokens in your requests. And the response will be successful only if you are accessing a resource that the resource token permits, based on the permission that the resource token was based on. And resource tokens are short-lived. By default, they last an hour. You can get them to last up to 24 hours, but they do then need to be refreshed. They're irrevocable. So once it's out there, it's out there. You can't suddenly cut off access to a resource token. Some of the considerations to be aware of. But what I said before about a unique aspect to this, if you go with resource tokens, there is a JavaScript SDK. There are a number of SDKs for client development against Cosmos DB. .NET, Java, obviously the big ones. But there's also a JavaScript, which is designed for browsers, right, obviously, or small client devices. And the JavaScript API has the ability to communicate directly to Cosmos DB, right? There's without a middle tier, as a kind of a two-tiered, more traditional, let's say ancient legacy client server type of architecture, where you need that middle tier only for the authentication flow during the one-time sign-on process, but as long as that those resource tokens haven't expired, you communicate directly to Cosmos DB and get a response directly back from Cosmos DB between the database and the front end with no middle tier. So that's resource tokens, and I have a demo that I normally have the time to show, but we're going to instead choose to use the time we have for demos to show you the Azure AD integration, which is much newer and much sexier, and definitely being well received and adopted. So this is role-based access controls. It will give you the obvious benefits that you could imagine. Based on your identity, you will have different permissions. They can be granular, but no more master key and no resource token. They just, you just don't use them anymore. You authenticate against an identity that you have in Azure AD. Auditing, of course, right? All the request headers are going to show who the client is, so you'll have all this rich authentication, and this works on a pretty simple permission model. There are several actions. There's actually more than these, but the most common one, right? Read item, write item, run query, right? There are actions that are defined, and what you do is you create role definitions against those actions. You define a bunch of roles. Each role has permission for one or more actions, but not other actions. So you have a role definition that defines the actions, and then you have role assignments that will associate each role definition with an identity in Azure AD. So, bless you. So what you need to do is you need to gather a couple of these IDs together. You might very well be familiar with this process of going into an Azure AD and capturing the tenant ID, also known as the directory ID. This is the one ID for the entire Azure AD. And then having these app registrations, which you can see I have. Here are 2 of them. So in this particular case, I'm going to create an identity for 2 different applications that should have 2 different sets of abilities and permissions. If I need an application to ingest data, okay, I don't need to allow it to query data. And if I might, it's because its purpose in life is to ingest data and not even read the data that it's ingesting necessarily. Whereas once that data has been ingested, I will have another application that should be able to read and query that data, but certainly not make any changes to it. That's the read-only application. So I'll have these 2 identities, one for the ingest-only demo and one for the read-only demo. Each of them has a client ID, of course. And those are going to be associated as well with a client secret, which is just going to be a password that we'll have to store in configuration. And that is how we will authenticate. And each, one application, the ingest-only application has, knows this client secret, and the read-only application knows this client secret, but neither one of them knows the other client secret, except in my demo here, because in my demo I just lumped everything together. But generally, you only give it the secret for the application, and then you need one more thing, and you only need this at one point in time. When you create these role definitions and role assignments that I was talking about, and you need to refer to each of these app registrations, you don't refer to them by their normal client ID or application ID, like this one here. You don't refer to them by these. Instead, you refer to them by their principal ID, which is yet another ID. It's unfortunately very confusing. But when you create those role definitions, and you'll see it in the PowerShell in a moment, you need to click on Enterprise Applications and capture that object ID, also known as the principal ID. They have all these terrible names that are very, very confusing. So this is the object ID / principal ID, which is different than the client ID / application ID, which each app registration has, which is different than the directory ID / tenant ID at the root level of the Azure AD. So you gather all those up, right? You're copying and pasting them into Notepad so that you have access to them. And now you have, again, so these principal IDs, again, are needed just for that one point in time. So these slides are maybe perhaps a little hard to read, but what you can see here is that I'm in PowerShell saying new Azure Cosmos DB SQL role definition. I'm creating one of these new role definitions, giving it a name called Cosmos Ingest Only Role, and these are the actions. It's hard to read, I'm sorry, but basically there's read metadata, which you always have to allow. It's like you can't do anything if you can't read the metadata. So that doesn't even count. You always have to have it. So besides that, there's only one permission or one action that I'm allowing on this role definition, and that is to create items in a container. Right? SQL databases / containers / items / create means the ability to create an item in a container, in a database with the SQL API. Plus, I've got an assignable scope here, where you can see that I'm then, oh, come on. There we go. Where I'm pointing to a specific database. I'm actually narrowing the scope of this definition to containers within this database, and it doesn't apply to any other database. And then it comes back in a few moments, and it has been created. And I create my role assignment, which again associates the role definition that I just created, which I refer to by name. There it says role definition name above the rectangle. Cosmos Ingest Only role, the role I just created. This should be associated with this principal ID. That's the principal ID, the object ID. And then it creates the role assignment, and that's it. And then I do the same thing again for the read-only role, definition and assignment. So I have ingest-only, role definition and assignment, and read-only, role definition and assignment. Let's have a live demo here. Let me jump over into PowerShell first of all and call get role definition to see what role definitions I have. You will see that I have the 2 that I just showed you on the slides, the Cosmos read-only role, now the read-only role allows read metadata, Like I said, at a minimum, you need that. But it also allows you to read items from a container, maybe execute a query as well, which is different, right? It's a select statement, or just read individual items. Or, I mean, if it's read-only, why not? Allow you to read from the change feed, right? If you're a read-only application. So, but if you look at the other one, for the ingest-only role, all you have is items create. That's all that guy can do. And then there's two built-in roles that we didn't create. They were just there. They're built in. So those are the two that I created, and then the role assignments themselves. Right? The principal ID is that object ID is tied to one. One is tied to the read-only, one is tied to the ingest-only, and that's the idea of those role definitions that I've associated. So that's all been set up. I'm going to head over to my application. Let me do a quick time check. Okay, we're good. And by the way, I have all the scripts here for PowerShell, even how to connect your account and so on, set your subscription, and then create the definitions and assignments. And now I've got these two demos, so let's go ahead and give it a run. And let's start with the ingest-only application. So I hit my breakpoint. I read from configuration. Well, let's go ahead and look at our app settings, and you'll see that there's no master key in here anywhere. I'm not authenticating with the master key. There's the endpoint that you still need, and then, well, you need three things. One of them is needed by all applications. It's the Azure Active Directory tenant ID or directory ID. And then the ingest-only application really only knows this secret. And the read-only application only knows this secret. This is a demo, so I put them together, but they would and should, of course, be isolated. Right now we're doing the ingest-only application, so we're working with these three values, that Azure AD, that client ID, and that client secret. So let's read that from configuration. We have an endpoint, we have the directory ID, client ID, and client secret. What you do is you create a new client secret credential that wraps that all up. You fire up a new Cosmos client, where normally that's the master key, but now it's that credential object instead. I am looking at a container called IoT in a database called IoT demo. Go over here, we'll see that we have this container at the moment is empty. I'm going to see if I can create an item. Yeah, I'll create an item with an ID of event 1, device ID, and some temperature. So this is some telemetry data. This is the IoT telemetry data, and oh yeah, it looks like it successfully created the new document. Now, can I read back the document I just created? I should not be able to. Even though I created it, I should not be able to read it back because I don't have that permission, and that I'm anticipating that with my try block. And you will get a Cosmos exception specifically with a 403 forbidden in the case that you don't have that access, that level of access. And certainly a select statement shall also be expected to fail, which it does with the same 403. So we're getting permission denied for our queries and for our point read, but we were able to successfully create a new document. Now on over in the read-only application, working our way through the same process of plucking out the Azure Active Directory ID, client ID, and client secret, only this time the client ID and the client secret are for a different application, an application that has a different set of role assignments to define the actions that are permitted by that client. But otherwise, it's an identical code to wrap all that up inside of a credential and supply that as the parameter to a new Cosmos client instead of a master key. Get access to the same container. Can I try to create one from this application? Create like a second document, event 2? No, now that fails with a 403, but that's the operation that succeeds in the ingest-only application. Now the inverse is true, and that is also as well the case for reading an item. Like I know the ID and the partition key, I can just read that one item very cheaply, and which works, or I can run a query. Like, give me all the documents, right? When I call actually, yes, calling read next async proves that it succeeded, right? Creating the iterator itself does not kick off the query. From the iterator, you call read next async with an await, and that has retrieved the first page of results of that query successfully, and there's your demo on Azure Active Directory. Yeah, so we're plowing through this very quickly, but that's the gist of it. 15 minutes to go. That should be enough for to cover our last kind of cool part of this session, which talks about encryption. So, any questions that can be tackled fairly quickly? Yeah.
Quick one. Just about scopes. So you can create a role definition of quite a broad scope. Like
You noticed that. You noticed while I was doing that. I started pointing it out, but I didn't continue to point out that when I created the role assignment, I further narrowed the scope. Is that what your question is about? So then the answer is then yes, you can have no scope, and it's just data the account wide. You can define a scope at the definition level, and then all assignments off that definition are scoped to that scope, but you can narrow that scope even at the assignment level. You can't broaden it. Cool, all right. So encryption, our third echelon of security, trying to keep things away, keep access limited, and keep things away from people who shouldn't be able to see it. So Cosmos DB has and always has had built-in server-side encryption. I think I started mentioning this, that you can't even disable it. Microsoft manages the keys. They're responsible for making sure that, a lost key doesn't mean you lose your data. It's like it's their responsibility. It's transparent. So all of your data gets that extra layer of encryption with a Microsoft managed key, but only on the server side. You actually never even get to see it in that encrypted state. But if Microsoft servers are hacked and SSD drives are stolen, and these things happen all the time. No, but should that occur, all the data is encrypted and in flight as well on the server side. Now you can, if you want to, or I should say, if you need to. This is not something you should do just because you can, but if required by your industry, if you have very stringent and strict policies that you have to have in place, you might want to encrypt using your own key that you manage. That, like, if you lose it, you can't go calling to Microsoft because they can't help you because you're managing the key, and so you have the key in Azure Key Vault. You're rotating it. You're responsible for it. You lose it, it's your loss. So that's why it's discouraged unless it's mandated. If it's mandated, you can do it, but then maintaining that key becomes your responsibility, and you still are getting that first level. Microsoft is going to encrypt your data and then encrypt it again if you opt in for a customer managed key encryption on the server side. That's a lot of encryption. And when you create a new account, or sometime after, you can, I wonder if you can change this once you create the account or not. But in any case, this is at account creation time on the encryption tab. The default is a service managed key, meaning Microsoft, or yours, and you enter the key URI. If you choose that option, you enter that path to Azure Key Vault. Now it's on you, right? Things get much more interesting with Always Encrypted. A quick review. Your application sends data out. It's not encrypted. It gets encrypted then using SSL to make its way across the web to the server side, where, like I said, you're going to get the Microsoft managed encryption and possibly your customer key encryption layer on top of that. And then it travels to persistent storage in Cosmos DB, again, encrypted in flight, and the same way back. But on the client side, things are entirely decrypted. So with client-side encryption, what we do is we rely on the SDK. We rely on the software developer kit for .NET, which will do the work of client-side cryptography operations, meaning encrypting and decrypting, all on the client side. Before it ever leaves your application, the data gets encrypted, it arrives back encrypted from the server, and only inside the application does then get decrypted. So there is a customer managed key involved here. Anyone familiar with Always Encrypted in SQL Server? Okay, it's a similar concept. Unfortunately, what they call a CMK in SQL Server is a column master key, not a customer managed key. Here it means customer managed key. But anyway, using that key, you encrypt, or the SDK on the client side encrypts specific properties within the document, not the entire document, but those sensitive properties, the credit card numbers, the passwords, those sorts of things. And then that gets encrypted, of course, over SSL, but if anyone should strip away that SSL encryption layer, they will still not be able to see the credit card number or the password, since they are encrypted client side. And then that extra layer of encryption on the server side gets added by Microsoft and optionally by you on top of that as well as it goes back and forth. And then as it returns, those properties are still encrypted, right? So they then get decrypted by the SDK for your application. Let's have a demo and we'll call it a wrap for the day. All right, well, not for your day, for my day. You have a whole day ahead of you, right, of sessions, right? So let's say I have got these two sensitive properties, the salary and the social. What I'm going to do is I'm going to create a CMK, a customer managed key, that will encrypt these two properties. I'm going to create two separate key vaults because I need two separate keys. Now that's, one key vault can have multiple keys, but each key vault has only one access policy, and I need two distinct access policies. I need an access policy, ordinary user applications are not granted any access, so they can retrieve data from the database, but they will never be able to see either the salary or the social. I'll have a staff application that I will want to include in the access policy that has the CMK for the salary property, but not the social. And then I'll have a service application, the most privileged application, that will be added to the access policies of both key vaults. So we will therefore have access to both CMKs, and it will be able to read both the salary and the social. So the social is the most sensitive data, available only to the service application. The staff application can see the salary, but not the social, and other user applications can see neither. Okay, that's our last demo with 10 minutes to go, right? All right, so let's see if we can get it all in. Let's see if we can fit all that in. So here I'm in Azure AD, and we were here already. We covered the Azure AD side of things. So instead, let me just show you that I've got here, yes, two key vaults. One for salary, one for social. Each one has a key, right, and a key with an ID, and access policies. Here, HR service and HR staff are both listed in this access policy. But for the other one, that has the encryption key for social security number, only the service application is listed here in the access policy for this key vault. So that's all set up, right? Those key vaults are all set up. Going over and looking at the code, this time now, encryption, we'll start with the service application and look at its app settings. So in order not to keep it as simple as possible, I've gone back to using the master key for connecting, authentication. I'm not using Azure AD for authentication. I'm only using the Azure AD aspects of this for encryption, just to keep us focused on encryption. I could obviously be authenticating with Azure AD as well, but I'm authenticating with the regular master key. The Azure AD stuff is needed just for the encryption. And in fact, only these three values are needed for normal operations. But if you're also going to create a container that is going to store encrypted documents, you need to create that container with a so-called encryption policy. which is immutable, by the way. So you set it at creation time and you can't change it. But we'll see some ways around that limitation in a moment. But if you need to create the container with an access policy, then you will also need the IDs of those two keys, which of course are useless if you're not listed in the access policy. But the service application is listed in the access policy, so the service application is actually going to create the container with the access policies, and then just using these values for the key IDs, and then just rely on these three. And if you look at the other application, at the staff application, it only has those three, right? Because the container is created. You only need these extra key values at container creation time. So let's go ahead and kick off the service application. Right, so I'm connecting with my normal endpoint and master key. I'm gaining access to the tenant ID of Azure Active Directory and the HR services client ID and client secret. Right? So now, basically I'm authenticating as this HR service client. I'm going to create a so-called key resolver. The credential is the same like you saw before for Azure AD authentication. It's the same. I have 6. It's the same client secret credential wrapper, but now we send that into a key resolver, which is specific for Azure Key Vault, and we create a new Cosmos client, again, connecting with the master key, but adding with encryption, attaching the key resolver, which is, again, in this case for Azure Key Vault. Create the database, human resources, get the database, and now let's create the so-called data encryption keys. That's pointing to my salary. The algorithms are hard-coded. It's kind of boilerplate. This creates the data encryption key, because actually the encryption is not done using the key that's in Key Vault. The key that's in Key Vault creates a DEK, and the DEK is what encrypts your data. So now that I've created my keys, I'm doing the same thing now for the other one, for the social. So for salary and social, they're both done. Now I'm ready to create my container. And I'm defining them with an include path. I'm saying, basically, encrypt the salary property using the salary DEK, and encrypt the social property using the social DEK, and now create the container. It's a Fluent API here that defines the container with the client encryption policy with the included paths we just described, 400 RUs of throughput. And now I'll add 2 employees. Look, there's salary, which is a complex property. It has 2 values beneath it. And there's the social. I'll create those 2 documents. And when I go over to the portal, Azure portal, and we look at the database, human resources, employees, items, the 2 items I just created. Well, look there. Look at the salary. Unreadable, encrypted. Look at the social, encrypted. And yes, the encryption policy is immutable, so you can't add a new property in the future. But in the case of salary, as you can see, it's a composite property. If I just started including a 3rd and a 4th child property, they would be encrypted as well. Last part of the demo, looking at 4 minutes. Right? Now that I've created them, I'm retrieving them with a point read. I did a point read operation, read item async, and also a query. And in both cases, I'm able to get back the salary and the social and read it. What about the less privileged HR staff application? All of this stuff is the same for the key resolver. I mean, it's actually simpler because I'm not creating the container. So all that extra code for getting the keys and defining the keys and defining the paths that get encrypted, that was all done into one time only. Here, I'm creating a client the same way. but I'm now going to do a select star, and it's going to fail. Or it should fail. Yeah, and it does. The client encryption key, blah, 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 it needs to be wrapped, blah, blah, blah. Basically, you don't have the right key. So I can no longer say select star, unable to retrieve all document with all properties. The only way to retrieve a document is with a subset of properties. I know I have access to the salary, but I don't have access to the SSN. So I have to exclude that SSN property and include all the others, including the salary property. And now you see that I am able to retrieve the documents, deserialize them, and gain access to the salary, but not the SSN. And when you put this all together with network level security, authentication, and encryption, you can really secure Cosmos DB. You can get it really locked down. I think I'm getting better at nailing it on time because that's the end of the presentation. Thank you. I'm really glad you came. We have 2 minutes if you want to throw out a quick question or two. But otherwise, thanks for coming. And feel free to fill out your evals, however you're supposed to submit your feedback. Let us know how we're doing. Really appreciate it. And thank you. Enjoy the rest of SQL Bits. Have a great day. Thanks. Bye.